Hey Econ kids, this is Module 46. It is the first unit of Section 9, okay, or the first module of Section 9, and it is the first time that we're really going to split off and do some specific to micro. Units 1 and 2 are both a micro and a macro kind of unit, so you get that both in both classes. So if you're taking micro and macroeconomics as a class, you're going to see those basic concepts and supply and demand skills in both subjects. But if you are only taking micro or only the micro exam, this is where we see sort of that split, and here's just some micro stuff. When we look at micro, we are looking specifically at, well, why do our supply and demand lines maybe look the way they do? So this first one on Mod 46 is talking about the income effect and the substitution effect, and then we'll get into elasticity. This first part talks about the law of demand. Why is this line downward sloping? And the first thing you're going to get is the substitution effect and the income effect. Now, my substitution effect is stating that because in my demand curve here, all right, when a price falls from P1 to P2, and if this good is a normal good, so we're just talking about all normal goods here. If the price falls, what's going to happen is I'm going to move down along this curve because I'm going to substitute this good for something else that maybe was more expensive. So for example, if I see the price of apples decrease, what's going to happen is I'm going to substitute those apples for maybe another fruit that I would have purchased. Let's say, oranges is the, sitting right there. So I could buy apples or oranges. If I see the price of apples go down, I'm going to substitute apples for oranges because the apple price went down. So the substitution effect basically says, you're always going to substitute these cheaper goods. So therefore, you're going to buy more quantity demanded of those goods. Therefore, it's going to be a downward sloping line. The income effect. The income effect for a normal good here states that if you have more income, right, you will buy more of a normal good. So because those apples were cheaper, you're going to buy more apples because you have more income. When you think about this, it's kind of like if you were to walk in a store and buy a shirt. Okay, so you're just going to buy some shirt in the store, you have it all picked out, you're going to spend $20. You walk in and the shirt's $10. What do? Well, you might buy two shirts because the price went down and now you're like, whoa, I feel like I have more money. Even though you don't have any more money. You walked in there with $20 to buy one shirt. But now, because the shirts are only $10, you can buy two shirts. You didn't have any more cash. It just felt like you have more cash. That's this income effect, right? It's not an increase in your income, it's an increase in purchasing power. Like you can buy more stuff with the income you have because you were looking for that good. Most of the time, what we will see is the substitution effect and the income effect reinforce each other, which is why we get this downward sloping line. All right? So that would be why the line is downward sloping. Well, why do we have to figure this out? Well, we have to figure this out because we're looking at elasticity, right? How elastic is this particular good? And elastic means responsive, right? Like, how stretchy is it? How responsive is it to something? And in this case, we're going to look at how responsive is this quantity demanded in relation to price. Okay, so an example might be, what if the price of gasoline doubles, right? That's in here. If the price of gasoline doubles, it probably doesn't look like this graph here, right? Gasoline probably looks more like this, okay? My slope of my line is going to be very steep. Why? Well, because I can't really substitute something for gas right now. You can't put something else in your car and have it, take you anywhere. So because the price of gasoline doubled from, let's say, P1 up here to P2, right? The price went up a whole bunch, but I did not lose much quantity demanded here because that particular good is very inelastic. Like you can raise the price, there's not a ton of response in terms of losing of the quantity because that good is hard to replace. Now, what if something like a price of a pencil double, okay? that's going to be a little bit different. If the price of a pencil doubles, right, you're going to see that look more like this. If the price went from here, quantity 1, P1, right, and let's say it went up to here, didn't even maybe double, maybe it just went up this much, you're going to see the price go up, but you're going to lose a whole bunch of quantity demanded, right? Why? Well, because there's a lot of good substitutes for pencils. You could write with a pen or something like that. Now, in some instances, could a pencil look like this one over here? Probably, right? If this, a pencil most of the time looks like this because you could use a pen, I don't know, type it, whatever. But it could look like this if you're doing something like a pencil when taking the ACT, right? Because now all of a sudden, if you jack up the price of a pencil and you need that number 2 lead pencil to fill in your little bubbles, then, maybe you will pay a whole bunch for a pencil and not lose a ton of quantity. This is what we're talking about in terms of elasticity, all right? So we can calculate elasticity. It's basically just the percent change in quantity divided by the percent change of price. And a lot of times that's going to be good enough to know. So percent change quantity divided by percent change in price equals elasticity of demand, let's say. So in this case, if they were to give you, a 40% price increase resulted in a 20% change in quantity, then you just put, 20 over 40 and you're done. But if they were giving you actual numbers, like, this much quantity changed to this much quantity, this price changed to this price, there is a way to do that too. And that's going to be our midpoint formula. So when we look at the midpoint formula, this is the only time where there's a little bit of math. And some people don't even teach the midpoint formula because 95% of the time, the exam's going to do this for you, and they're just going to give you percent change. But every once in a while, they give you super weird numbers. You can just plug them into this midpoint formula, and it always works. If I get a number that's greater than 1 when I do this, my line is said to be elastic, which means my line is going to look a lot more like the pencil, okay? So my line is going to look a lot like this. That is going to be, if you think about it this way, elastic, okay? Elastic. When you get a downward sloping line that is pretty flat. If you see, if you're going to get elasticity less than 1, your line is going to look something like this, right? More like gas. And this is inelastic, okay? So that looks like an I in elastic. That's the way it works. This one, put a line up here. It looks like like elastic. Now, sometimes your line doesn't look like either one of these. But if you're in your brain, you can think it's acting like this. That's all you really need to know. All right. Now, if you get something that's elastic, right, or unit elastic, I mean, if you get something that is your E is equal to 1. Now, the odds of that happening, very rare, right? Because that means you have to do all that math on the top, all that math on the bottom, and you have to figure out like, this is, it equaled 1. What are the odds? If that's the case, you're probably looking at a very small part of a line, like zoomed in, and your line is very much like this. And you're looking at just this portion of a line where if you drop the price, it's going to be the same change in quantity. So when you look at that one as a unit elastic type line, this is like if my price went from 5 to 4, my units increased from 4 to 5, something like that. If that happens, this is a unit elastic line, and that doesn't happen very often. But that is something that kids like to pick on a test because for some reason they think unit elastic happens all the time. Unit elastic happens rare. Most of the time you're going to get something that's inelastic or elastic depending on what that good is, and we can talk about those types of goods. All right? If you think about midpoint formula, the only other thing I would say about doing this, and we'll practice it, but what you're seeing there is the second quantity minus the first quantity over the second quantity plus the first quantity divided by 2. Now that should be in parentheses too, like both those things, because you have to do the quantity separate from the price, and then you're gonna divide that quantity number divided by the price number to get your elasticity. And those two lines on the side are absolute value, because you're always gonna get a negative number due to a downward sloping demand curve. So when you look at that midpoint formula, it seems sometimes intimidating, but once you plug it in, it's not really that hard. And as long as you can remember, that answers every single elasticity question. And the elasticity questions are on the test more often than you think. So with that being said, we'll practice some of those in class. Don't freak out if you're like, oh my gosh, that looks like a bunch of math. It's not too bad. And again, down here, this question, percent change quantity divided by percent change price, is what you're going to get most of the time. But from what I know of even seniors in econ, doing percents is just as difficult as anything else. Like, you might as well just do the midpoint formula, because if you can't calculate a percent, then at least you can put the numbers in. So when you look at it, you can do both. You'll probably get this one down here. Some people, like I said, don't even teach the midpoint formula, but we'll teach it so you can do it, because it's really just basic math, right? Adding and subtracting, multiplying and dividing. Till next time.